Hello again. In the next 4 or 5 videos, we'll be solving questions on standing or stationary waves. Now, this is a very important and broad topic. Even when you study sound waves next year in A2, we will apply the same concepts for standing and stationary waves. So that's why I've picked 5 questions to target different conceptual points for this topic. Let's look at the first question. In this question, we have to convert phase difference, which is given in the units of radians, into a path difference, which we will measure in units of wavelength lambda. And these are the options. I've chosen this question because everything that follows will be built up on this basic concept. When we talk about constructive, destructive interference, all the conditions, we will be talking in terms of phase difference and path difference of waves. So it's really important to understand these two things. Now, here we have a traveling wave. And in the first diagram, I've labeled the x-axis, the different points on x-axis, I've labeled them in units of radians. In the second diagram, I've labeled the same points, but this time I've labeled them in units of wavelength. Let's see what is the difference between the two. So for the first one, we start at 0, and we know that a wave completes its cycle in 360 degrees, right? So 360 degrees, we know it's complete 2 pi, it's a complete circle, which is 2 pi radians. So the wave will complete its cycle, which is this complete cycle, in 2 pi radians. So that's why this point D will be 2 pi. And then in reference to complete wave, we can label all the other points. So if this is 2 pi, this midpoint B will be pi, and then midpoint of 0 and B will be pi over 2, similarly 3 pi over 2, and this point right here will be 3 pi, and this will be 4 pi. In the second diagram, we want to label the same points, but this time in units of wavelength. So again, one complete wavelength is this. So this point D, we will label this point as 1 lambda. Okay, this is a complete wavelength, so 1 lambda. And then in reference to 1 lambda, we can label all the other points. Point B will be half of lambda. This point right here will be a quarter of lambda, and this point will be 3/4 of lambda. Now, what I want you to figure out is these 3 points. So this, I've already labeled this point. This is 3 lambda, and this one. So you can pause the video and see if you can figure out what should I label this point, and similarly for this diagram. I will tell you the answer. So if you look at how the pattern is going in the numerator, we have 1 pi over 2, then we had 2 pi over 2, but the 2's got cancelled and we got pi, and then 3 pi over 2, and then 4 pi over 2, but if you simplify 4 pi over 2, you get 2 pi, so that's why this is 2 pi. So if you follow this pattern, this point must be, after 4 pi over 2, this point must be 5 pi over 2, and this point must have been 6 pi over 2, but if you simplify 6 over 2, you get 3. That's why this is 3 pi. And similarly, this point must be 7 pi over 2. Similarly here, the pattern for wavelength is lambda over 4. The next one must have been 2 lambda over 4, but when you simplify it, you get lambda over 2. Then 3 lambda over 4, 4 lambda over 4, the 4's got cancelled, you got lambda. This point must be 5 lambda over 4, 5 lambda over 4. This must have this must be 6 lambda over 4. This must be 7 lambda over 4, and this point must be 8 lambda over 4, which simplifies and gives you 2 lambda, right? So this is how you label these points. Now, the important thing to remember is that if you are labeling these points in units of radians, and I ask you what is the difference between point D and point B, let's say, the answer will be given as a phase difference, because we are labeling these points as angles, right? So whenever you are labeling these points as angles, we call it phase difference if you find the difference between 2 points. So in this case, let's say the difference between point B and point D is pi radians. So point D is at 2 pi radians, point B is at pi radians. The difference is 1 pi radian. Similarly, if you are labeling these points as in units of wavelength, lambda, and I ask you the same question, what is the difference between point B and point D? The difference will be measured as a path difference, okay? In this case, the path difference between point B and point D is half lambda. You can see point B is lambda over 2, point D is lambda. So the difference is 1/2 lambda. Now here comes the most important concept, which if you understand, you will be able to solve the question that we saw on the previous page. Consider the following question. If I ask you which of these 2 points in the first graph, which of the 2 points have a phase difference of 1 pi, okay? So which of the 2 points have a phase difference of 1 pi radians? Now, the answer is, of course, not just one answer. You can give multiple answers. This is the trick. So you can say that point, let's call it A. The difference between point A and point B here is pi radians, but also the difference between point D and point D is also pi radians. And similarly, point D and point whatever this point is also pi radians. So there are multiple possible answers for this question, as we just saw. So the important thing to understand is, where are you starting from? What is your origin? If you are starting here at this point, then the point that would correspond to phase difference of 1 pi will be point B. On the other hand, if let's say my starting point is this 3 pi, so this is my origin, and I ask you what is the phase difference of 1 pi relative to this position, the answer will be point H, okay? And similarly for the wavelength also, it really depends on what is your origin. All of multiple points can have the same phase difference depending on the origin. Now coming back to this question, the question is 1.5 radians correspond to a path difference of which of the following options is correct for path difference. So let's go back to these diagrams. So let's see where we have 1.5 pi radians. This is the point C. So this point that we called 3 pi over 2 is 1.5 pi radian. Now the question is, which of the points on this graph, because we want to compare phase difference with path difference, which of the points here will correspond to the same phase difference of 1.5 pi radians, okay? So remember, we are starting from here, and this is the phase difference that we are talking about of 1.5 pi radians. So on this graph, you can see there are many possible answers. For example, if you start from this point, this is our origin, then 3 over 4 lambda will correspond to 1.5 pi phase difference. 3 over 4 lambda path difference will correspond to 1.5 pi phase difference. But the problem is that this 3 over 4 lambda is not in the options, right? So this is where a lot of students get confused and cannot answer this question. But you have to use the trick that I explained. You have to shift your origin, right? So let's look at how we can answer this question by shifting our origin. Let's say if we start at this point D. So we are starting at 1 complete lambda, but now since this is our origin, we can call it 0, and then a path difference of 1.5 lambda or 3 over 4 lambda will correspond to this point right here, which is 7 pi over 4 lambda, right? You see this length and this length, they are exactly the same. The only difference is that we have just shifted our origin. And now if you go back, you can see it is option B. So remember this trick. Although 7 pi over 4 lambda and 3 pi over 4 lambda will give you different answers, but in terms of path difference, they are the same lengths. We are just shifting our origin. We will use these concepts in the upcoming videos, so make sure you understand this video. If you did not understand, you can tell me in the comments or watch the video again, but make sure you understand this concept before solving the next questions.